Alright, hey guys, glad you made it to part 5. This will be the last part. We're going to be looking at domain and range, everything that deals with domain and range. So we're going to go ahead and start with our line here. Now, I know that this is we're going to do this slightly out of order, but I always want you guys to think about it this way. Anytime that you're given something and they ask you for either your domain or your range, I want you to ask yourself first, is it continuous or is it discrete? All continuous means is that it's going to be connected with a line. So if we see, even though we have 3 points here, they're connected by one line. Since they're connected by a line, we can say that this is continuous. The only time that we would say if something's discrete is if we had points like this, right? Different little bits of data. So since this is connected, we're going to go ahead and say first that this is continuous. Now, whenever we have continuous equations, we're going to write our inequalities as something like 0 to 10. Right, something like that. This part here, that's going to be with continuous functions. We want to write our equations this way. With discrete equations, we want to make sure that we're writing them something like x such that, and whatever your numbers are. Let me close it off. Right, you want to do something like this with discrete equations. Again, if we're listing points, that's what we want to do. We want to list every single point. If we have a line, then we can say, hey, it starts here, it ends here, right? Something like that. So since this is continuous, this is what we want our equations to look like. Now, this is the way that I teach it in my class. You want to think about your domain. So your domain, first of all, is our x variable, which means that we're going to be looking at our x-axis. So your x-axis is the one that goes left to right. We do what I call lazy measuring. So we want to kind of think about the x-axis here as a ruler. In fact, let me grab a highlighter. Let me highlight this a little bit. We want to think about this line right here as a ruler. So there's my ruler. I start at the origin. I start at 0, 0. We always go left to right. So we always want to see, okay, where does it start on my left side? So I start here at 0, 0 at the origin. I want to first count backwards to see where my graph starts. So if I count backwards, that's going to be 1 box, 2 box, 3 boxes. That's where the line, that's where the graph starts. All right, the graph starts there. Again, I'm using this x-axis to measure it. So right now it starts at -3. So my domain, I can go ahead and say that it starts at -3. I'm going to go ahead and leave a little bit of space. And I'm going to write the other endpoint. Where does it end? So again, I start back at my origin, and we're going to go over 1, 2, and that's where it ends, right? It ends right there at 2. So there's going to be -3, leave a little bit of space, all the way to 2. Since we're talking about domain, I'm going to put an X in the middle. And then the way that I teach it in my class is we listen to Irreplaceable by Beyonce, which you're on YouTube, so you can very easily go look up Irreplaceable, play it for a bit. One of the big lines in it is Beyonce whenever she says to the left, to the left. So our inequalities are always going to point to the left, right? That's why we look at that, or that's why we listen to that song in class when we look at that. All right, our inequalities also, so we look at the endpoints as well. So at -3, we have a closed circle, so we can underline this. At +2, we have a closed circle as well, so we can underline that. My domain is going to be -3 less than or equal to x less than or equal to 2. My range, now with my range, we're going to use a different thing to measure. So my range is my y, so we're going to be using our y-axis to measure. And so I want to think about it now going up and down this way. So I'm going to make this in a different color. Now we're going to be looking at our domain and range using that to measure it. Okay? So again, we want to start at our origin, 0, 0. We always go down from the bottom to the top. Right, so we always start with lowest to highest. So we're going to go and start at 0, 0. The lowest part of my graph is going to be here, right? Would we agree that that's the lowest point? So we just go down 1. Down 1 is just going to be -1. The highest part of my graph, again, I start back at 0, 0. It's going to be 1, 2. It's not at 2. That's not the highest point. The highest point is going to be way up here. We're going to go up 1, 2, 3, 4, right? The highest point on my graph is going to be 4. So again, -1, leave a little bit of space, 4. This time we're talking about range. Range is our y, so we want to put a y in the middle. Then we have less than. Again, Beyonce tells us to the left, They point to the left. And then I can equal at -1, I have a closed circle, so I can draw a line there. At +4, I have a closed circle, so I can put a line there. And so my range is from -1 all the way to 4. -1 less than or equal to y, less than or equal to 4. Alright, let's go over to the other side, domain and range of, this time we have a lot of dots, and the dots are not connected with points, so we can go ahead and say that this is discrete. Again, they're not connected. And we're going to do the same thing. Domain is going to be my x values, this is going to be my range is my y values. We start off by measuring with our x-axis. So we start off by measuring with this. This time, since I have points, I want to be looking at this individual points at a time. So I'll be just listing their x value individually. So again, we always go left to right. So we're going to go and start with our leftmost point. Leftmost point, if I trace it down, is going to come to here, right? If I start at my origin, I go back 1, 2, 3. That's going to be at -3. Remember that this time we have to open up our little squiggly brace. We're going to do x such that we're going to have -3. Our next point is going to be this one, and so that's going to be back 1. So at -1. Our next point is this one. That's going to be, again, start from origin. We're going to count over 1. Point after that is going to be this one. This one's going to be over 1, 2, 3, 4. And then finally, that's going to be our last point. So we're going to go over 1, 2, 3, 4, 5, 6. Close up our brace and we're done. We're done with our domain. Range, we're going to do up and down just like before. So let me go ahead and highlight this so that we can see what ruler we're using to measure. Ruler we're going to be using is going to be up and down. Alright, so now we're using the orange one to measure. We're going to be measuring, you kind of want to think about it, we're measuring the height of each of these points. Right, we start at the lowest and we go to the highest. So the lowest point in this case is going to be that one. If I trace it back to this, again looking up and down, that's going to be at 0. So same thing, we're going to open up our brace. This time we have y such that 0. The second highest is if I go up one, I'm level with this one now. So that's going to be 1, comma. If I go up 2, 1, 2, now I'm level with that one and that one. Right? I'm not going to write 2 twice. I only have to write it once. I know that sometimes students write it twice. I mean, we, as teachers, I don't think we'll count off, but you just know that you only have to write it once. And then if I go up 1, 2, 3, I get up to the very, very last one, or very, very top one. So 3 is going to be my last number. I can close it off and I'm done. Alright, we're going to go and flip this over to the back. It says, Mr. Beaumont traveled an average of 70 miles an hour on his road trip from Houston, Texas to Miami, Florida. Would the graph of this data be discrete or continuous? Now we want to think about this. Driving. If I wanted to make a graph of his driving, right? Let's say that this is time and this is distance. Distance that he's traveled so far. Would my graph be a lot of points? Like there he is, he's here, and then magically he now appears here, and then magically he is now there. Then he's in Dallas, and now all of a sudden he's in, New Orleans or something like that. Does he just magically get there, or does it take time for him to get there? You want to think about your graphs. How would it look? Time and distance. I think most of us would agree that a graph, if we're traveling, would look something like that. Right, our speed stays the same, but slowly but surely we're slowly going up, getting more and more distance as the time passes, right? So I think that most of us would agree that our graph would look something like this, which if it's going to be a line, it's going to be continuous. So our answer to this would be continuous, right? It's going to be one continuous line. It's just going to be steady eddy all the way through until we get to Miami. Okay. This one says, Ms. Bell grades 5 algebra quizzes every 10 minutes. Would the graph of this data be discrete or continuous? Now, you always want to think about how they give you the information. It says she grades 5 every 10 minutes. So if we were making a graph for this, this would be, I guess, quizzes. This, I guess, this would be time. Right, our data would be, if we were given something like this to graph, it would be at 10 minutes, 20 minutes, 30 minutes, 40 minutes, and then it would be 5 quizzes, 10 quizzes, 15 quizzes, 20 quizzes, right, something like that. So at 10 minutes she would have 5, at 20 minutes she would have 10, 30, 15, 40, 20, right, something like that. Now we wouldn't connect these points, and here's why. At 12 minutes, or let's say even at 11 minutes, at 11 minutes would she have like 6 or 6.5 or 6.25 or 6 point, whatever of a test graded? Like, we wouldn't really count it that way. We would say, hey, at, every 10 minutes, again, exactly how it says it, every 10 minutes she's going to have this much. So this one's actually going to be discrete. Again, because we would count how many tests or how many quizzes she finished in that time. Finally, last one, it says Kira was driving in her neighborhood and approached a stop sign. When she applied the brakes, it took 4.5 seconds to come to a complete stop from a speed of 20 miles per hour. If Kira creates a graph of her speed versus time as she applies the brake, determine the answers to the following. And I'm sorry about the beeping. They're running tests here at school. Alright, so she's going 20 miles an hour. And she slams on the brakes, right? She hits the brakes, and it takes her 4.5 seconds to come to a complete stop. Alright, so once again, you always want to try to, anytime that they give you something like this and they ask you, hey, is it continuous or discrete? Try to make yourself a graph, try to make yourself a table, try to visualize what's happening. So with me, I would think that this would be time. This would be probably something like speed. So she starts off, before we even start counting, she's going 20 miles an hour. Right? 20 miles per hour. She slams on her brakes. And the car immediately starts dropping in speed. Boom, there it goes. Dropping in speed, dropping in speed, dropping in speed, until it finally comes to a stop after 4.5 seconds. Right, so there would be like 4, 3, 2, 1, something like that, like right seconds, and then obviously miles or whatever. And we agree that it wouldn't be like she's at 20 miles and then magically she's at 10. It would gradually slow down until she finally stopped. Right, so this would be one continuous, flow of slowing down, slowing down, slowing down until she stops. So since it's one continuous flow and it's one continuous thing, and in fact we're talking about time and we're talking about speed, this is going to be something that's going to be continuous. Okay, so we have continuous functions. My domain, once again we're going to look at domain. Domain again is my x values. Or I'm going to be looking at my x-axis, so I'm going to be looking at these numbers. And I'm going to be measuring, so how long does it take me to stop? Well, I start, right, we always look at start time, end time, right? So my domain is going to be from my start, which is 0, all the way to where I end, which is 4.5. Right, again, I'm looking at this graph, trying to measure this graph using this ruler, I guess you can kind of think about it. We're talking about domain, so x goes in the middle, less than. I can equal 0 and I can equal 4.5, so I'm going to put a line under both of those. There's my domain. My range is going to be up and down. So we're going to be looking at this. And obviously I didn't fill in a lot of this, but it goes all the way to 20. Right, so now we're looking up and down. Again, we started at our lowest. Our lowest, again, we trace this one all the way back over. Our lowest is at 0. Our highest is at 20, so we're going to go 0 to 20. Again, we're talking about range, so y goes in the middle, less than, less than. Again, Beyonce tells me to the left, less than or equal to, less than or equal to. Again, because I can equal 0, right? I equal 0 when I stop, and I equal 20 whenever I start. I'm driving 20 miles an hour. All right, so there's my domain, there's my range. Again, we kind of have to draw this, we kind of have to think about it a little bit first, but there's our domain and range solved for us. All right, guys, good luck on y'all's test tomorrow. Make sure you guys get plenty of sleep, and make sure that you guys look over any stuff that didn't make sense to you, or that as you come into the room, that you're asking your teacher, hey, I didn't understand, whatever, number 8. Can you explain this a little bit more for me, before the test starts, something like that. I would also encourage you guys, if you're still watching this video, make sure that you guys go to the bathroom or do anything else that you need to do, because the rules are that we can't let you guys go or leave the room during the test. So go to the bathroom beforehand.